Hello YouTube. Well, you're probably looking at what's on the screen at the moment. This is in fact a wiring diagram for a CB1, which is very similar to the NC23. And you're probably looking at it and going, yeah, don't like that, it's black and white, it's really not very clear, don't really understand it. Well, yeah, this is what we used to have to deal with back in the good old days. Thankfully, most wiring diagrams now come in colour. Just move that a bit. And again, it's still a bit of a jumble of stuff, a bit easier to understand, but yeah, there are a few tricks to understanding it. But before we get too involved in the wiring diagram, let me show you something else. Now, I'm sure even if you don't live in London, or even the UK for that matter, you probably recognise this. Let's just zoom in a little bit. As a map of the London Underground, and it's helped thousands of tourists and locals to actually understand what's going on and how to get around London. So what we've got is a whole series of train lines. They're all colour coded. And everything's in nice straight lines. Now, the London Underground map wasn't always like this. Originally, the London Underground had a lot less lines for a start and a lot fewer stations. But all the maps were actually geographically correct. So the central line, for instance, which runs across here in red, this actually, on the original maps, used to do something like that. And in 1931, a guy called Harry Beck came up with the idea of simplifying the London Underground map. And rather than having everything geographically correct, he sort of stretched it out, squashed it up, and straightened everything out so that everything was in straight lines or at 45-degree angles. So as I said, the lines themselves were already colour coded. He just made them a bit easier to understand by making everything straighter. And this was heralded as a real design classic. You'll see pictures on t-shirts and posters of it, and it's actually in the London Design Museum as a great piece of design. The reality is, Harry Beck in 1931 didn't actually come up with that much of an original idea. He merely copied what electrical engineers were doing all the time. And so the London Underground map owes a lot to electrical diagrams and wiring diagrams, such as that. They are one and the same thing. So if you can actually find your way around the London Underground, then you can find your way around a wiring diagram. It's not that scary. So there's a slight little detour, but hopefully that puts you in the right frame of mind on how to approach a wiring diagram. The other problem is with the wiring diagram, if we just zoom out a bit, the zoom function on this camera is rubbish. Right. And it's either all or nothing. Let's get a better camera. There, that'll do us. The other problem is, as I mentioned in the last video, all the wiring circuits themselves are pretty simple. The problem is, there's a whole load of them, and looking at them all together, it does all get a bit complicated. So, rather than look at the whole wiring diagram, let's break it down into its main circuits. Now, there are 4 circuits on a motorbike. So there's the first circuit here, and that's your power supply and charging circuit. Then you have the ignition circuit, then you have the lighting circuit, and finally the one that does get a little bit complicated, all the accessories and ancillaries. So if we actually break the wiring diagram into its component parts, you can see you're looking at fewer parts to start off with, a lot less lines, and it all becomes a lot less complicated. So let's start at our first wiring diagram. And this is, I mean, I'm going to call it the supply and charging circuit. It probably has other names with other people. So what we have over here, you'll have your battery. Then you have your starter solenoid, which is this device here. So we looked at that in the last video. And from there, basically everything goes from the battery through your main fuse, which is this 30 amp fuse in the top. I think we're a bit too zoomed in to see this very clearly. And it comes along this red wire, along here, and up to your ignition switch. Now I'm going to talk a little bit more about the various symbols as we go along. But basically from the ignition switch it can go one of two ways. When the ignition is turned on, it will go down this red and black wire and into your fuse box, and from there it will then go through the various fuses off to your different circuits. So obviously you can see with these two down the bottom here, I've actually removed those because we don't want to look at those. But the key thing is there is one circuit that we do need to worry about, and that's our starter circuit. So there we go. On the solenoid we actually have a couple of things going on. So you have the actual relay up the top here, which activates the starter motor over here. Now of course the starter motor isn't there anywhere near the battery in reality, it'll be somewhere down here. But to simplify the diagram, they've moved the starter motor on the diagram. And from there you will have the switch. If we look down the bottom of the wiring diagram, this is your starter switch and this is your kill switch. So the power comes from this red and black wire, goes through a fuse, down this black wire, and it comes to the starter switch. And this symbol represents a switch, and this represents a momentary switch. Ordinary switches are represented slightly differently, as you'll see a bit later on. So we come down the black wire. When the switch is closed, current can flow through this yellow and red wire back up to our starter solenoid, operate the magnetic component of the solenoid, which then goes through the earth. Now on the earth we have various little inhibitors to stop you starting the motor in gear. So the first one is, in order for it to carry on down earth and eventually get back to the negative terminal on your battery, which is here, we have this little diode, and it can either go through the neutral switch, so as long as the bike is in neutral, that circuit is closed, and it can go through this wire and through the neutral switch. And it comes this funny little Christmas tree diagram. Now I did say that in the previous video, in order to reduce the amount of wiring, the bikes are wired negative earth. So what you'll see is this little symbol here indicates there is something that is then connected to the frame. And you can see, if we look at the battery, there's also the same symbol up the top, which is also connected to the frame. So you'll just have to imagine, anywhere you see these symbols, they are actually connected together. If for some reason you're not in neutral, well, the current has the option coming up through this this wire here, through this wire here, and going through the clutch switch and eventually earthing out through the clutch switch. So you can either start the motorbike with the bike in neutral or with the clutch pulled in. So it's to stop you basically starting the bike and the bike jumping forward. So all these little wires are there purely to operate the starter switch. And that is all that indicated. You can see also this comes up to our neutral light, which will have a positive supply. But we'll look at that because it kind of crosses over into two areas. It should really be in the accessory circuit, but you can't have the starting and power circuit without it, so I've had to include it. The other part of the circuit we need to look at is the alternator and the regulator rectifier. Obviously, all the while the bike is running, we're drawing current from the battery and gradually discharging the battery. So we need some way of recharging the battery, and that's what the alternator does. So the alternator is located in the right-hand crankcase of the engine, and what it consists of is a series of electrical windings and a big magnet that spins around it, and that creates a little current, and it comes through these 3 wires. Now the alternator, as the name implies, it actually produces an alternating current, so an AC current, the same as you've got in your household. Unfortunately, motorbikes run on direct current, so all these 3 wires come into your regulator rectifier, and the regulator rectifier does 2 things. First of all, it regulates the current, so it converts it from an alternating current into a direct current. It then regulates it, and what that does is it monitors how charged up your battery is and whether or not to send electricity back through this wire and back into the battery to charge it. If the battery is fully charged, then the regulator rectifier will say, no, I don't need any charge, and it actually dissipates the excess charge as heat. That's why most regulator rectifiers are finned. Unfortunately, on Hondas of this era, they generally weren't finned, they weren't that great, and they tended to overheat, and they tended to self-destruct. So that's why the regulator rectifier is quite a common fault on these bikes. Thankfully, modern bikes, or modern replacement parts, are finned, they're a bit more robust. But the other problem is the wiring path from the regulator rectifier back to the battery is a little bit convoluted. So I'm actually going to modify the wiring on the bike. So you've got a direct connection from the regulator rectifier to the positive terminal. Makes it easier for the regulator rectifier to monitor it. And also the earth. Now it actually shows on here an earth that goes all the way there through to your earth point. The reality is what most people do is there's just a little short wire that comes out of the regulator rectifier, and that screws into the subframe. But of course the subframe will have been painted like mine has been. It's held onto the main frame by 4 bolts, and again you've got paint in the holes, so you haven't got a very good connection. So again that messes up the reading that the regulator rectifier gets. So again, I'm going to change this earth. I'm going to make sure there is a direct earth connection from the regulator rectifier to the main frame, so the main aluminium frame, and we'll look at all that later. But anyway, that's your first circuit. So it's the power supply through the ignition switch, the switch that operates the starter, and this part here, the charging circuit. Not so complicated when you look at it like that, is it? The second circuit, this is the ignition circuit, and again it's exactly the same principle. I've removed the battery, I've removed everything we don't need, so we'll just assume that obviously there's power coming from the battery into the fuse box, and from now on we're going to work everything from the fuse box. So again, you've got this black lead, black wire. And the nice thing is with Hondas is they always use the same colours for all their bikes. So anything that is permanently live and permanently connected to the battery will be red. Anything that is switched and gets its power from the fuse box will be black, or possibly black with a different coloured tracer, usually black and white or black and brown. So we come from here and it will come down and it goes through your kill switch. Obviously if the kill switch is open, then you won't get any power to the coils or to the CDI unit. So we come from the kill switch, and you can see there's power, goes into each individual coil, and it also goes into the CDI unit. Now the CDI unit is basically a whole series of switches, electrical switches, but it's all done on microchips. Now from our point of view, a CDI is just one of these magical black boxes. They either work or they don't work. I'm not going to teach you how to diagnose problems in a CDI unit. So the CDI unit, the power comes in and then it'll come back out the different coils. So you can see you've got a yellow wire with a blue tracer and a blue wire with a yellow tracer. One goes to one pair of coils and one goes to the other pair of coils. Also connected to your CDI is your pulse generator coils. Now these are in the left hand casing of the bike, and again it's just basically a little arm that spins around and it passes through a hall sensor. Now a hall sensor is just a magnetic switch. So like I said, everything switches. And what that does is as the little wheel passes past the hall sensor, it breaks a magnetic field and sends a signal. So again, we've got different coloured leads. Some send power to the actual sensors and some actually send signals back to the CDI to tell it when to fire the sparks. There we go. Of course, we've got our earth connection because everything needs an earth. And then finally there's this weird little orange and blue wire. Now this confuses all sorts of people. And what that is there was a regulation in Japan that motorbikes weren't allowed to exceed 112 miles per hour, or 400s on a restricted license, weren't allowed to exceed 112 miles an hour. So this blue and orange wire comes up to your speedo, and when the speedo registers over 112 miles an hour, what this does is it actually cuts the power to the ignition circuit and prevents you creating the spark, well, the coils working and sparks occurring above 112 miles an hour. So this is one of those things that everyone likes to bypass, and we'll look at bypassing that because obviously I won't be having a speedo, so I need to fool the CDI unit into thinking that there is still a speedo present, and also a speedo that never registers 112 miles an hour. The other thing you get from here, if we look at the yellow and blue wire, and this blue and yellow wire, is they both come up to the fuel relay, and this is what activates the fuel cut-off relay. So again, you've got a positive coming in, you get a signal from either of these wires which turns the relay on and enables power to come down this black and white wire to your fuel pump. So if your fuel pump's not working, very often it could be that the relay for the fuel pump isn't getting a signal from the coils, or the actual relay is broken. And again, the fuel pump then comes back down, green wire, back to your earth. What else have we got? Let's have a look over this side. So you have the speed limiter light, again not always present, and then we have the tachometer, the tacho. And again, that gets its signal through this green and yellow wire that comes from the CDI. So the CDI unit sends pulses along this wire to actually control the tacho, which again needs an initial power source, which is this black and white wire, and it needs to earth again. So that's our ignition circuit. We have the lighting circuit. Now, not really going to worry too much about this because we don't use it on the race bike, but as you can see, you've got two different feeds from the fuse box up the top. One feed will do the high beam, and one feed will actually do the low beam and the tail lights. And that's because, as we said in the last video, your headlights over here require a much higher capacity, or higher wattage than the low lights, so they have to run through the relay here. Now I'm not going to go through everything. You can see there's wires that feed the bulbs in the instruments, so you can see them at night. There's your tail lights, but what I will look at is down here, and these little boxes. So what I've done is I've taken this box, which is your main light switch, and I've enlarged it. So what you can see is when the switch is off in 0, nothing is connected. When we put it onto P, or side lights, what happens is you'll have the feed coming through here, which is this wire here, and that will come into this terminal, battery 3, and then when we switch it into the first setting, the P, it will allow electricity to flow through the switch here, come back out through this brown and white wire, which then goes on to feed your tail lights, your side lights, and your illumination lights for the clocks. If we put it onto main beam, again that circuit stays open, but it also opens up this circuit, which is from battery 4. So that's this brown wire here, and it comes out, and it also comes across, comes out HL, which is this black wire, which then goes on to feed your dip switch, which again divides the current up through either through the white wires, the low beam, or through this blue and white wire, which operates the relay, the high beam. So again, it's all the same sort of thing, we're just getting rid of everything that we don't need. I'm not going to walk you through all this circuit, there is so much to cover, and you'll see that, hang on, we've talked about that, yes we have, we've talked about that, and that's because a lot of these ancillary components are fed through the ancillary circuit, so they should be included here. But the key thing is you've got things like your indicators, so you can see the blue wire which goes up there, and the orange wire which comes again to your signal, to your turn switch. Got things like your horn, and again all this clutch bypass, and the neutral switch bypass, the starter switch, and again your neutral light, your oil pressure light. And these ones are classic examples of where the switch is actually in the negative side of the circuit rather than the positive side of the circuit, and that's because they're obviously screwed into the engine, and so they'll bypass through the engine, which in turn is connected to the frame. So there's wiring diagrams really. Like I said, at first glance, when you look at one of the black and white ones, it all looks pretty scary and overpowering. We then make it in colour, it looks a bit clearer, but the trick is to actually break it down into the 4 individual circuits. So as I said, there are 4 circuits. There's your charging and supply circuit, there's your ignition circuit, your lighting circuit, and then your ancillaries. So when you're dealing with a problem on any particular part of the bike, so say you've got a problem with the headlights, just ignore every other circuit, so the charging circuit, the ignition circuit, and just look at the wires that are involved in the circuit that you're actually dealing with. Hopefully that's made wiring diagrams a little bit simpler and a bit less scary. Like I said, if you can manage your way around the London Underground and cope with the map of the London Underground, really a wiring diagram is no different. There we go. Thanks ever so much for watching, and yeah, I can't put it off any longer. I'm now going to have to get my tools out and the soldering iron and the pliers. I'm going to start wiring up the bike. So I'm not going to show you everything on it, but I'll just run you through a few key points and bits of interest as we're doing them. So I'll see you in the next video.